Okay, this is for section 2.8, and 2.8, I'm actually changing the title and we're not covering it all. We're just going to do graphing linear inequalities. I'm not that worried about absolute value inequalities, so we're going to do graphing linear inequalities. Yes. Thank you.
Yeah.
And that's good to ask. And on these, I think you actually probably did this in ALG2, but it's been a while. Okay, I'm going to go through like 4 examples. Okay, and this will probably be easier on the graph paper. They will just say graph, and instead of it being a linear equation, it's going to be an inequality. So if I said graph y is greater than or equal to 2x plus 3, the way I approach it is I always graph it as though it's equal to first. So I want to get the boundary. So I'm going to change that to an equal sign just to get the boundary. And it's in the form y equals mx plus b. You always want to try to get it in that form. So you graph the b value first, so you know it goes through at positive 3 on the y-axis. So go up 3 and put a point. Okay, and then the slope is 2, and that's like 2 over 1. So that's your rise over your run. So from that point, not from the origin, but from that point, you're going to go up 2 and go to the right 1 and put a point. Go up 2 to the right 1. And you can do that several times until you can see your line. And then as best you can use your protractors, make a straight line. And on these are lines, so put an arrow on both ends. Okay, now you do have to check what this sign is. If this is greater than or equal to, less than or equal to, that boundary is going to be solid. So on this one, it is a solid boundary. Okay, and then the way I do it, I always test 0, 0. I test 0, 0 back in the original, 0 for x, 0 for y, and shade the side that's true. So on this, test 0, 0, and shade the side that's true. So if we put 0 back, you'd have 0 is greater than or equal to 2 times 0 is 0 plus 3. So 0 is greater than or equal to 3? No, that's false. So 0, 0 is not part of the graph, so shade the other side. So you're going to shade this side. Okay, and you can use, just put some other lines there, or if you have another different highlighter, different colored pencil, okay, or just use some marks. So you're basically shading that side. And it would end up to be, it's basically all of this side. Any point in there would make that inequality true. Okay? Anything over on this side, where the 0, 0 is, would make that inequality false. Am I right? You did this in Algebra 1?
Yeah.
Okay. But it's been a while. Okay?
So how do you know which sign?
I always test 0, 0. And so I'm testing 0, 0, but it was false. You always shade the side that's true.
So you shade the side that doesn't. Yeah, that's what I was going to.
What? No, you don't shade the side that's 0, 0. No.
It doesn't.
If it's a true statement, you shade it. Yeah, yeah. Okay. Like 0, 0 was false up there, so I shade the other side. If 0, 0, if that would have been a true statement, then I'd shade the side that's true. Okay. Okay, let's try another one. Okay. Okay, so for example 2. Okay, now I'm going to change, and on this one, I'm changing the inequality symbol to y is less than a negative 3/4 x minus 2. So as soon as you see this symbol, it's not going to be a solid boundary. It's only when it's equal to greater than or equal to, less than or equal to, it's solid. So this one is going to be a dashed boundary. Okay, it's in the right form, y by itself, so it's y and a negative 3/4 x minus 2. And on this, if you do it as equal, you're going to graph the b value first, so it's going to go and cross at negative 2 on the y-axis. The slope is rise over run. So from that point, you're going to go down 3 and then to the right 4 and put a point. Down 3 and to the right 4. Or you can go up 3 and to the left 4. Up 3 and to the left 4. And then this is where you have to look at this. If it's less than or greater than, it's a dashed boundary. Okay, so this should be dashed. Yours probably looks a little bit better with the straight edges, but it should be something like that.
So when it's not less than or equal to?
Yeah, if it's got the equals, yeah. If it's just less than, greater than, it's dashed. As soon as it has that equal sign, it's solid. Okay, now I test 0, 0. Okay, so I'm going to test 1 point. And the easiest one to test is 0, 0. So I'm going to go back to the original and put 0 in for x and 0 in for y. Okay, and I would get 0 is less than negative 2. That's not true. So shade the other side. Okay, so I'm going to shade 0, 0 is not true, so I'm going to shade this side. Okay, so everything on this side. Now, notice anything on the boundary would not work, okay, because it's less than. Like if you tested a point on the boundary, that's still not going to work. And that's why you dash the boundary, okay? Everybody okay with the test in 0, 0? Yeah.
So if it's
Did you answer your own question? Okay, okay, that's all right. Okay, 2 more examples. 2 special cases. Okay, x is greater than or equal to 4. Okay, I graph it as though it's equal to first. I always think and graph that. X equals a number is what type of line?
vertical.
Vertical. So at x equals 4, and it is equal. So at x equals 4, there is a vertical line going down at x equals 4. Same thing, I test 0. Put 0, 0. If you put 0 in there, 0 is 0. Go back to this. Is 0 greater than or equal to 4?
No.
No. So shade the other side. X is greater than or equal to 4. So greater than or equal to is to the right. That'd be everything over here. Okay? So any x value in there would make that a true statement. Okay, so that's a special case where you have a vertical line. Okay? Everybody good with that one? Okay, last one. Okay, another special case. Let's do y is less than negative 2. Y equals, I graph it as though it's equal to first. Y equals negative 2. Horizontal line, yep, at negative 2. So at negative 2, we got a line, horizontal line. Y equals a number is always a horizontal line. Oh, and I need to dash this, sorry. Oh, I made a mistake. Caught me at a mistake. Dashed. Yeah. It's a good thing you said that. I'd have to record this all over again. Okay, so dash, boundary. Okay, then test 0. Yeah. Yep. So yeah, so if you have less than or equal to, greater than or equal to, it's a solid line. Greater than, less than, it's dashed. Okay. As soon as you have that equal sign, it's solid. Okay, now we need to go back and showed y is less than -2. So test 0. If you put 0 in there, you get 0 is less than -2. No. So thank you for the recording. Okay. So less than is everything below. Okay? Okay? Okay, those are the 4 graphs that we're going to do on the graphing inequalities. Okay? And so that you know ahead of time for the rest of this week. I guess we can go through.